What I'd like you to do in this pendulum experiment, which you can easily do at home, is to take a mass tied to a string, choose 5 different heights. Obviously, the range of those heights will make a difference to your ability to measure the time. We're going to look at the period of one swing. The period of a swing is the time it takes to move from a starting point here and then come back to its original position. So the time for one swing to the left and then back to the original position. I want you to measure the time for 10 swings, and I want you to change the length 5 times. The table here illustrates how we differentiate between instrument uncertainty and average uncertainty. For your 5 lengths here, you're going to measure the length of the pendulum. You have to state the instrument uncertainty in your ruler as you measure length. Then you're going to take the time for 10 swings for each length, but you're going to have to do that 3 times because it isn't the most accurate experiment and it's best to take averages in order to reduce random errors. Once you've worked out your 3, you do the same for the 5 different lengths. You finally complete your table by doing 2 things. You time the average for 10 swings. That means you add them all up, divide by 3 to give your average for 10 swings. And I want you to then work out the average uncertainty in the time for 10 swings. So you're going to have an uncertainty value here, 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 and here, which will probably be different. I also need you then finally to state the instrument uncertainty. Remember, this is the uncertainty in your stopwatch. Next week, we'll talk about how to work out the actual uncertainty for 1 swing as opposed to 10 swings, but we'll talk about that next week. For now, we are just finding the difference between instrument uncertainty and average uncertainty.